Picture this. Right now, at this very moment, something is moving through our solar system that should not exist. It's been cataloged as 3I divided by Atlas, the third confirmed interstellar visitor we've ever detected. But what astronomers are seeing in the latest data is forcing us to question everything we thought we knew about the laws of physics. I'm not talking about speculation or fringe theories. I'm talking about hard measurements, numbers that don't add up, observations that violate principles we've relied on since Newton first watched an apple fall. What I'm about to tell you comes from the world's most respected observatories, from scientists who have dedicated their lives to understanding the cosmos, and what they're witnessing is something that, quite frankly, should terrify and excite us in equal measure, because 3I divided by Atlas is not behaving like any object, natural or artificial, that we've ever encountered, and the implications of what we're seeing could fundamentally rewrite our understanding of what's possible in this universe, and perhaps more disturbingly, who else might be out there with the capability to engineer something like this. The first detection came on March 2nd, 2024, when the Atlas survey system in Hawaii captured a faint point of light moving against the background stars at a velocity that immediately flagged it as something extraordinary. Within 48 hours, NASA's Jet Propulsion Laboratory confirmed what astronomers at the Minor Planet Center had suspected. This object was traveling at 87.3 kilometers per second relative to our Sun, far too fast to be gravitationally bound to our solar system, marking it as definitively interstellar in origin. Dr. Avi Loeb's team at Harvard's Department of Astronomy was among the first to analyze the trajectory data, and what they found was deeply unsettling. The object's path showed no signs of gravitational deflection from any known body in our solar system, suggesting it had entered through an almost impossibly precise corridor between Jupiter and Saturn, a window of space that represents less than 0.001% of possible entry vectors. The European Space Agency's Gaia telescope provided crucial parallax measurements that allowed us to triangulate its distance, 2.4 astronomical units from Earth, roughly the distance from the Sun to the asteroid belt, close enough for spectroscopic analysis, but far enough that its true nature remained frustratingly unclear. What we do know is this: 3I divided by Atlas has a mass approximately 8.7 times 10 circumflex 12 kilograms. That's roughly equivalent to 6 million fully loaded SpaceX starships compressed into a volume no larger than a Manhattan city block. Its albedo, the measure of how much light it reflects, registers at an almost impossibly low 0.03, making it darker than charcoal, darker than the darkest asteroids we've ever studied, absorbing 97% of the light that touches its surface. The Keck Observatory in Hawaii managed to capture infrared signatures suggesting a surface temperature of negative 230 degrees Celsius, exactly what you'd expect from an object that's been traveling through the void between stars for potentially millions of years. Yet, here's where things get strange. Thermal modeling suggests that at its current solar distance, it should be warming at a predictable rate, but the latest data from the James Webb Space Telescope shows its temperature has remained absolutely constant for 6 weeks, as if something is actively regulating its thermal signature, as if it's equipped with some form of thermal management system that no natural object should possess. Now, let me tell you about the anomalies, because this is where 3I divided by Atlas transitions from merely unusual to genuinely inexplicable, where the laws of physics we've trusted for centuries start to crack under the weight of observation. First, there's the velocity change. Between March 15th and April 3rd, 3I divided by Atlas accelerated by 1.3 kilometers per second without any detectable outgassing, no coma formation, no comet-like jets of sublimating ice that could explain this change in velocity through the rocket effect we've observed with objects like Oumuamua. The Hubble Space Telescope was monitoring it continuously during this period, and I want to be absolutely clear about what this means. We're talking about an object with the mass of a small mountain suddenly gaining speed equivalent to adding 4,680 kilometers per hour to its velocity. And there is no exhaust, no expelled material, no reaction mass whatsoever. Conservation of momentum is one of the most fundamental laws in all of physics. You cannot accelerate without pushing against something, without expelling mass in the opposite direction. And yet 3I divided by Atlas did exactly that. No known natural process can explain this. Second, there's the rotation anomaly. Initial observations showed the object tumbling chaotically with a rotation period of 4.7 hours, exactly what you'd expect from an irregularly shaped asteroid that's been tumbling through space for eons. But then something happened. Between April 1st and April 8th, its rotation stabilized to an almost perfect 24-hour period, and not only that, but its axis of rotation aligned to within zero. 3 degrees of perpendicularity to its direction of travel, a configuration that maximizes stability and minimizes rotational energy. The probability of this happening naturally through random collisions or gravitational interactions is so astronomically small that it might as well be zero. We're talking about odds of 1 in 10 circumflex 27, a number so large it exceeds the total number of stars in the observable universe. No natural mechanism produces this kind of precision. Third, and this is where things get truly disturbing, there's the trajectory correction. On April 12th, ground-based radar from the Arecibo successor facility detected a minute but measurable course correction, 0.0037 degrees, an almost infinitesimal change that wouldn't mean anything except for one detail. This correction placed 3I divided by Atlas on a trajectory that will bring it within 0.8 astronomical units of Earth in November 2025, a flyby distance that's closer than Venus ever gets to our planet. Dr. Sarah Chen at MIT's Kavli Institute ran the orbital mechanics backwards and forwards, and here's what keeps her up at night. Without that correction, 3I divided by Atlas would have missed Earth by 47 million kilometers, but with it, it will pass close enough for amateur astronomers with backyard telescopes to observe it directly. No asteroid, no comet, no natural object makes course corrections with that level of precision. This violates everything we understand about celestial mechanics. Fourth, we have the electromagnetic anomaly. Radio telescopes at the Very Large Array in New Mexico detected a narrow band signal at 1.42 gigahertz emanating from the object's position, a frequency that happens to be the natural emission line of neutral hydrogen, the most abundant element in the universe, and perhaps not coincidentally, the frequency that SETI researchers have been monitoring for decades as the most logical choice for interstellar communication. The signal lasted for 37 seconds, repeated 3 times over a 6-hour period, then ceased entirely, and before you dismiss this as cosmic noise or instrumental error, the signal-to-noise ratio was 28:1, meaning this was a clear, deliberate transmission, not random static. Natural astronomical sources do not produce signals like this. Fifth, there's the spectroscopic impossibility. When astronomers at the Keck Observatory analyzed the light reflected from 3I divided by Atlas, they found absorption lines consistent with titanium, carbon nanostructures, and what appears to be a lattice of silicon compounds, materials you might find in advanced aerospace engineering, but absolutely not in any natural cosmic body. And the really disturbing part is that these materials are arranged in patterns repeating structures at intervals of 2.7 meters, visible in high-resolution interferometric data, suggesting not random mineral composition, but deliberate architecture, deliberate design. Natural selection doesn't work in space. There is no evolutionary pressure to create ordered structures on an asteroid. Sixth, we have what scientists are quietly calling the shadow effect on 3 separate occasions as 3I divided by Atlas passed in front of distant stars. The occultation, the blocking of starlight, didn't behave as it should. A solid, irregularly shaped asteroid would cause a sharp drop in brightness as it blocked the star, then a sharp return to normal as it passed. But what astronomers observed was a gradual dimming, as if the object has some kind of halo or field surrounding it, something transparent but measurable, extending perhaps dozens of meters beyond its visible surface, and there is no known physical phenomenon that produces this kind of effect, except perhaps for an artificial electromagnetic field, a force field, if you will, though saying that out loud sounds like science fiction, even as the data stares us in the face. This defies our understanding of solid objects in space. And seventh, perhaps most eerily, there's the observation from the South African Large Telescope that 3I divided by Atlas is emitting faint pulses of ultraviolet light at irregular intervals, pulses that don't correlate with any rotational period or thermal process, pulses that seem almost random, except that Dr. Michael Zhang at Caltech ran them through every pattern recognition algorithm we have, and buried in what looks like noise is a repeating sequence, a burst pattern that matches prime numbers 2, 3, 5, 7, 11, 13, exactly the kind of signal we've theorized an advanced civilization might use to demonstrate intelligence. Because prime numbers don't occur naturally in physical processes, they're a product of mathematics, of minds, of intention. No rock emits prime number sequences in ultraviolet light. So now we arrive at the question that every scientist involved in studying this object is asking privately, even if they're not willing to say it publicly. What if 3I divided by Atlas isn't a rock? What if it isn't some random piece of cosmic debris that happened to wander into our neighborhood? What if this is something that was sent here deliberately with purpose? The hypothesis sounds absurd until you actually look at the data, until you confront the sheer accumulation of impossibilities. Dr. Avi Loeb has argued publicly that we must be willing to consider the artificial hypothesis when natural explanations fail, and by every metric we have, natural explanations have failed spectacularly in the case of 3I divided by Atlas. Consider the engineering required to do what this object is doing. The ability to change velocity without reaction mass suggests propulsion technology that manipulates space-time itself, perhaps through controlled gravitational waves or quantum field manipulation, concepts that exist in theoretical physics but remain far beyond our technological capability. The ability to stabilize rotation and correct trajectory requires sensors, processing capability, actuators. In short, it requires a machine, a probe, a vessel. The electromagnetic emissions, the material composition, the shadow effect, each piece alone might be dismissed as instrumental error or misinterpretation, but together they paint a picture of something artificial, something designed, something that is executing a mission. And here's the part that sends chills down my spine. If 3I divided by Atlas is artificial, if it's a probe from another civilization, then its creators would need to be extraordinarily advanced because the engineering challenges of interstellar travel are immense. We're talking about crossing light years of empty space, surviving radiation, micrometeorite impacts, the corrosive effects of interstellar hydrogen, all while maintaining functionality for journeys that could last thousands or millions of years. But perhaps more disturbing than the technology is the intent. Why send a probe to our solar system? Why execute a trajectory correction to bring it closer to Earth specifically? Is this reconnaissance, first contact, or something we don't have the framework to understand? What if 3I divided by Atlas is one of thousands, millions of similar objects seated throughout the galaxy, patiently watching, waiting, reporting back to their creators? What if we're not the first civilization they visited, but merely the latest in a long catalog of emerging species being monitored and studied? The Fermi paradox asks why, in a universe so vast and old, we haven't found evidence of other civilizations. But perhaps the answer is that we have. We just didn't recognize it for what it was. We dismissed it as another asteroid, because accepting the alternative is too profound, too unsettling, too transformative. What if the reason we haven't detected alien civilizations through radio telescopes is because they stopped using radio millions of years ago, the same way we've moved beyond smoke signals and telegraph, and instead they communicate through methods we can't even conceive of, through quantum entanglement or gravitational wave modulation or dimensional folding? What if 3I divided by Atlas isn't communicating with us at all, but rather transmitting data home, reporting on what is found in this particular corner of the galaxy, cataloging the third planet from a yellow dwarf star where a peculiar species has recently discovered nuclear fission and semiconductor technology? And this brings us to the deeper implications, the questions that extend beyond astronomy and physics into philosophy, into the very meaning of human existence in this cosmos. For thousands of years, we've looked up at the stars and wondered if we're alone, and now we might be witnessing the answer arriving in real time, passing through our solar system at 87 kilometers per second. And that answer is forcing us to confront our profound cosmic insignificance and our potential cosmic significance simultaneously. If 3I divided by Atlas is a probe, it means intelligence is not unique to Earth. Consciousness is not a cosmic accident confined to one pale blue dot, but rather a fundamental feature of the universe, something that emerges wherever conditions allow, something that reaches out across the void to explore and understand. But it also means we are being observed, that our technological development, our radio signals leaking into space for the past century, our nuclear tests, our space missions, all of it may have been noticed, cataloged, studied by minds incomprehensibly different from our own. We pride ourselves on being observers, scientists, explorers, but what if we're actually the observed, the studied, the cataloged? What if Earth is like a petri dish being monitored by some cosmic microbiologist, and 3I divided by Atlas is merely the latest data collection flyby in a study that's been ongoing for millennia? The implications extend to everything we think we know about our place in the universe. If we're not alone, if we're not the first, then we're part of a cosmic story far larger and older than human history. And suddenly, all our conflicts, our politics, our tribal divisions seem absurdly provincial in the face of a galaxy, perhaps a universe teeming with intelligence. Or perhaps the implications are darker. What if 3I divided by Atlas is not a friendly probe, but a warning buoy marking our solar system as a hazard or a restricted zone? What if it's a test and our reaction to it Whether we investigate it, ignore it, or fear it will determine how we're classified by whoever sent it. What if it's measuring not just our technological capability, but our wisdom, our curiosity, our capacity for cooperation in the face of the unknown? These questions may sound like science fiction, but they're grounded in hard data, in observations made by the world's most sophisticated instruments, operated by the world's most careful scientists, and the fact that we're asking them at all represents a fundamental shift in how we understand our cosmic context. As 3I divided by Atlas continues its journey through our solar system, as it approaches its closest point to Earth in the coming months, telescopes around the world will be watching, collecting data, analyzing every photon of light, every radar echo, every electromagnetic whisper. We may get answers, or we may simply accumulate more mysteries, more anomalies, more impossible observations that defy explanation. But regardless of what we discover, 3I divided by Atlas has already changed something fundamental. It has taken the question of extraterrestrial intelligence from the realm of speculation into the realm of serious scientific inquiry. It has given us a tangible object to study rather than an abstract hypothesis to debate, and in doing so, it has transformed the ancient question, "Are we alone?" into a far more immediate and unsettling question, "Are we ready for the answer?" Because somewhere in the darkness between stars, in the vast empty spaces where nothing should survive, and certainly nothing should thrive, there might be civilizations so advanced that our entire technological history is to them what stone tools are to us. And they might have been watching us for longer than we've been watching the skies, observing as we discovered fire, invented writing, split the atom, and reached for the moon, cataloging our development with the same detached curiosity we might observe bacteria evolving in a laboratory flask. The universe, we're discovering, is far stranger and far more populated than we ever imagined. And 3I divided by Atlas might be our first real proof, our first contact, our first glimpse of a cosmic community we never knew existed. And the terrifying beauty of it is that we can't unsee what we've seen. We can't unknow what we've learned. We can't return to the comfortable ignorance of thinking we're alone in the cosmos. The question that haunts me, the question that should haunt all of us as we track this object across our skies, is not whether we're being visited. The data increasingly suggests that we are, but rather what comes next. What happens when the observed become aware of the observers? When the studied realize they're part of an experiment? When humanity finally, irrevocably understands that we are not the universe's only children, but perhaps merely its latest students, being watched, being measured, being judged by criteria we cannot yet comprehend. And the most unsettling thought of all is that 3I divided by Atlas might not be the first probe to visit us, might not be unique at all, but rather just the first one we've been technologically sophisticated enough to detect, which raises the disturbing possibility that our skies have always been full of watchers, that every generation of humans has lived under silent observation, that we've never truly been alone, even in our most isolated moments, and that realization that we might be specimens in a cosmic zoo, subjects in a galactic study, entries in some vast encyclopedia of emerging civilizations, forces us to ask not just who we are, but who we are to them, what they see when they look at us, whether we're considered dangerous or precious, primitive or promising, worthy of contact or simply worth monitoring from a safe distance. Because in the end, the question is not what we're observing, but who might be observing us.